Remember from last video, we used two rules to solve the question. Today we are going to prove these two rules, which is the derivative of sine of x is equal to cosine of x, and the derivative of cosine of x is equal to negative sine of x. So let's start with the first question. Again, if we want to solve this question, we need to use the definition of derivatives. So let's restate the first definition of derivatives, which is f prime of x is equal to limit as h approaches 0 of f x plus h minus f of x over h. Okay? So again, this is going to be super helpful for us. Now let's start our proof. Okay? So by the definition of derivatives, we know that the derivative of sine of x will be equal to limit as h approaches 0 of sine of x plus h minus sine of x over h. Now we need to use the addition rule, which let me just write it right here. So the addition rule says that if we have sine a plus b, then this is basically equal to sine a cosine b plus sine b cosine a. Okay? So this is another rule which is really helpful in proving our rule. So implementing this rule, we get the derivative of sine of x is equal to limit as h approaches 0 of sine x cosine of h plus sine h cosine of x minus sine of x over h. Okay? So now let's factor. Okay, so I'm running out of space, but that's okay. So let's factor out let's factor out the sine of x. So we get sine of x on the outside. On the inside, we have cosine of h minus 1, finally plus sine of h cosine of x over h. Now remember that h is approaching 0, which means that we have your cosine 0 minus 1. So what's cosine 0? Okay, cosine 0 is 1. Okay, so this is 0. Okay, because it's 1 minus 1, so this is 0. So this whole expression equal to 0. So let's simplify this a bit. Now, so therefore we are left with sine of h times cosine of x on the numerator and h on the bottom. And now remember from video 3, we proved yet another theorem, which is that limit h approaches, let's not say h, x approaches 0, sine x over x is equal to 1. This is the exact time where this comes in handy, because look right here, okay? This is exactly the same with the one we just proved in video 3. So implementing this rule, we get limit as h approaches 0 of 1 times cosine of x, which equals to cosine of x. And thus we have proven that the derivative of sine of x is equal to cosine of x. Okay? So I believe that after our proof of the derivative of sine of x is equal to cosine of x, you are also be able to do the same with the derivative of cosine of x. So make sure to pause for a moment and just try it by yourself. Okay, so now let's just do it together. Let me erase everything here. So the proof of the second equation is also pretty similar. So let's again start with proof. Now, again, starting with the definition of derivatives, cosine of x is equal to limit as h approaches 0 of sine of x plus h minus, oh sorry, not sine, cosine of h plus x minus cosine of x over h. Now using the rule, the addition rule is called, we get limit h approaches 0 of oh yeah. So for cosine, the addition rule is just slightly different. So let me write it right here. So for cosine, if we have cosine a plus b, then our rule changes to cosine a cosine b minus cosine a, sorry, sine a sine b. Okay? Therefore, we have here cosine x cosine h minus sine x sine h minus cosine over h. Okay, start right here. Now again, let's factor out the cosine of x at the outside. So therefore we have cosine of h minus 1 minus sine x times sine h over h. Now remember that, again, h is approaching 0, which means that this expression here is equal to 0. So this is equal to 0, okay? So what we're left with is, again, negative sine x times sine h over h. And now we know that this fraction here is equal to 1. Therefore, we basically get 1 times negative sine of x, which is negative sine of x. And thus, we have proven that the derivative of cosine of x is equal to negative sine of x. Okay, so these are the two proofs for the two rules that we used in the last video.